forged in fire, and shaped by precision, strength takes form. Orus knowledge. Discover how the world is made.
Stainless steel is one of the most versatile and widely used materials in the modern world, playing a crucial role in industries ranging from construction and automotive to medical devices and kitchenware. Its unique properties, including resistance to corrosion, high strength, and a sleek appearance, make it indispensable in countless applications. But how is this wonder material made? The process of manufacturing stainless steel is a complex and fascinating journey that involves multiple stages, from the selection of raw materials to the final finishing touches. In this video, we'll take you through each step of the process, shedding light on the science and engineering that goes into creating this remarkable alloy. The story of stainless steel begins with the selection of the right raw materials. The primary component of stainless steel is iron, which is extracted from iron ore found in the Earth's crust. Iron ore is rich in iron oxides and must be refined to extract pure iron. This is done in a blast furnace, where the iron ore is heated to extremely high temperatures, around 1,700 degrees Celsius, along with coke, a form of carbon, and limestone. The intense heat causes the iron ore to melt, and the carbon from the coke reacts with the oxygen in the iron ore to form carbon dioxide, leaving behind molten iron. This molten iron, also known as pig iron, is the starting point for making stainless steel. However, stainless steel is much more than just iron. Its defining characteristic is its resistance to rust and corrosion, which is achieved by adding specific alloying elements, most notably chromium. Chromium is essential because it reacts with oxygen to form a thin, invisible layer of chromium oxide on the surface of the steel. This oxide layer is what gives stainless steel its stainless property, as it prevents further oxidation and corrosion of the metal beneath. To achieve this, chromium is added to the molten iron in the form of ferrochrome, an alloy of iron and chromium. Typically, stainless steel contains at least 10.5% chromium by weight, although the exact percentage can vary depending on the grade of stainless steel being produced. The addition of chromium is just the beginning. Depending on the desired properties of the final product, other elements such as nickel, molybdenum, and manganese may also be added to the molten steel. Nickel, for example, enhances the corrosion resistance of stainless steel and gives it a more lustrous finish. Molybdenum increases the steel's resistance to pitting and crevice corrosion, which is especially important in environments with high chloride content, such as marine applications. Manganese improves the steel's strength and hardness. These alloying elements are carefully measured and added to the molten steel in precise quantities, as even small variations can significantly impact the properties of the final product. Once the alloying elements have been added and thoroughly mixed with the molten iron, the next step is to remove any impurities that might have been introduced during the process. This is done through a process known as argon-oxygen decarburization, AOD. In AOD, a mixture of argon and oxygen is injected into the molten steel. The oxygen reacts with carbon and other impurities to form gases that can be removed, while the argon helps control the temperature and prevent excessive oxidation of the chromium. The result is a purer form of stainless steel, with a carefully controlled composition that ensures the desired properties are achieved. After the AOD process, the molten stainless steel is ready to be cast into solid form. This is typically done using a method called continuous casting, where the molten steel is poured into a water-cooled mold. As the steel cools, it solidifies into a long, continuous slab or billet, which can then be cut into smaller sections as needed. Continuous casting is preferred because it allows for the production of large quantities of stainless steel with consistent quality. The slabs or billets are then allowed to cool further before being sent to the next stage of the manufacturing process. The next step in the production of stainless steel is hot rolling. The cooled slabs or billets are reheated to a temperature of around 1,200 degrees Celsius and pass through a series of rollers. These rollers apply pressure to the steel, gradually reducing its thickness and shaping it into the desired form. Hot rolling not only shapes the steel, but also improves its mechanical properties by refining the grain structure. The steel can be rolled into various forms, such as sheets, plates, bars, or wires, depending on the intended application. After hot rolling, the steel is allowed to cool down again before moving on to further processing. At this point, the stainless steel still has a rough, oxidized surface that needs to be cleaned and finished. This is where the process of pickling comes in. Pickling involves immersing the steel in an acid bath, usually a mixture of hydrochloric acid and nitric acid. The acid removes the oxide scale and any other surface impurities, leaving behind a clean, smooth surface. In some cases, additional treatments such as electropolishing may be used to achieve an even higher level of surface finish, particularly for applications where aesthetics are important, such as in kitchenware or architectural components. Once the stainless steel has been pickled and cleaned, it is ready for the final finishing processes. These processes vary depending on the intended use of the steel and can include cold rolling, annealing, and surface finishing. Cold rolling involves passing the steel through rollers at room temperature to achieve a precise thickness and improve its surface finish. Annealing is a heat treatment process that relieves internal stresses in the steel, making it easier to work with and enhancing its ductility. Surface finishing can involve a variety of techniques, such as brushing, grinding, or polishing, to achieve the desired texture and appearance. The final product may have a mirror-like shine, a matte finish, or a textured surface, depending on the customer's specifications. The production of stainless steel doesn't end with the final finishing. Quality control is a critical aspect of the manufacturing process, ensuring that the steel meets the required standards for strength, corrosion resistance, and other properties. Samples of the steel are taken at various stages of production and subjected to rigorous testing, including chemical analysis, mechanical testing, and microstructural examination. These tests verify that the composition and properties of the steel are within the specified limits and that there are no defects that could compromise its performance. Only after passing these tests is the stainless steel considered ready for use. Stainless steel is then ready to be shipped to manufacturers who will transform it into the products we use every day. It could become part of a kitchen appliance, a piece of medical equipment, a structural component in a building, or even a piece of jewelry. The versatility of stainless steel is one of its greatest strengths, and its journey from raw materials to finished product is a testament to the ingenuity and precision of modern metallurgy. The production of stainless steel is a complex and highly controlled process that requires expertise in both materials, science, and engineering. From the selection of raw materials to the final finishing touches, each step is carefully designed to ensure that the steel possesses the properties needed for its intended use. Whether it's the chromium that provides corrosion resistance, the nickel that enhances durability, or the precision rolling that achieves the perfect thickness, every aspect of the process contributes to the creation of a material that is both strong and beautiful. So the next time you see a shiny piece of stainless steel, take a moment to appreciate the intricate and fascinating journey it has taken to reach you.